Alright, Algebra 2 Trig Honor students, so just want to continue with the lecture on Chapter 6, the logarithmic functions, the exponential functions. So today we want to talk about the properties of logarithm. So we do have a couple properties here, so you guys need to recognize or try to memorize it. So the structure of condensing form to expanded form, or the expanded form to the condensed form. So you see that in a minute. So anytime that we see anything like log of or log base b of x times y, so this one is always considered the condensed form because that x times y, it's all written together. But the things that we can always separate them. So the way to separate them is written as log base b of x plus log base b of y. So again, the left hand side here is called a condensed form. And then the right hand side here is called the expanded form. And the purpose of doing this, well, you see that in a minute. Because sometimes we can go from right to left. Sometimes we can go from left to right to simplify the expression. So we can either simplify the equation or we can just use that to solve for the equation. So the name for this property is called the product to sum. Kind of like the property of an exponent, product to sum. And now, the other one, what we have here, it's a quotient. So let's say we do have log base b of x over y. So that one is written as log base b of x minus log base b of y. Don't worry about that. I'm going to erase this so I can show you the word for solving this one. So this one is called the quotient to difference. Well, for those you might be wondering, the exponential form, are they quite similar? So for the exponential form, multiplying, that means we need to add the exponent. And then exponential form, if that's considered division, we need to subtract the power. Okay, so now what about for the third one? The third one is a little bit different. So the third one is called the power to coefficient. So anytime they see that the power r like this, you can always bring down the number all the way to the front. All the way to the front of log. So it's a power to coefficient. And then the fourth one, and this one will be even weirder. So let's say we do have log base b of x. This one can be written as log of x over log of b. So the last one is called a change of base. So we're going to use that later. Oops, again, something wrong with the pen. So this one is called change of base formula. So we got 1, 2, 3, 4. Okay, so now to look at that, number 40. So number 40, we do have log base. Well, the base is not given, so that means 10. Okay, the base is not given, that's 10. So anytime they see like two different log with different quantities, so that means we can always condense them. So the way to condense them, so we can use the first property. Well, product to sum or sum to product, depends on which way that you started with, right? So this one, the structure is given as a sum. So once you condense it, so we do have log base 10 of the quantity, 3 minus x times 7. So that equals 1. So what I did here, I just applied the first property, so sum to product. So now, before we convert it, so this one, we can just put it in as log base 10 of 21 minus 7x. Because that, the product here, you want to distribute. And now for those you might be wondering, what about the log base 10? How do we get rid of that log base 10? Well, we can just either raise up this one to the power to the base of 10, or we can convert it back to the exponential form. So exponential form is written as 10 to the first power So that equals 21 minus 7x. So we got 10 equals 21 minus 7x. So in other words, 7x equals 21 minus 10, which is what, 11? And then x equals 11 over 7. Now, got to be careful with this. By the time that we put in the number, well, this one, let's see. Okay, one thing I would like to talk about, the x value here. The way you can check the work, you can always plug in the number back to the original equation and then see whether it's 1 or not. Another thing that you want to check, if the quantity of the log is considered a negative number, so that means that would be considered the invalid solution. Why is that? Because the log function is always considered like this. Here's the parent graph for the log function. So let's say we have y equals log of x. As you can see that the value of h is considered 0, the vertical asymptote. So anytime they see the quantity for x here, so that means x must be greater than 0. Well, because that's the domain. So anytime that you find out the x value for the quantity, so the whole quantity here, make sure that it's going to be greater than 0. So notice the quantity of log must be greater than 0. So this one here, so 3 minus 11 over 7, is that greater than 0? It is, right? Because 21 over 7 minus 11 over 7, that's considered what? 10 over 7. So it's still considered positive, so which is good. So 11 over 7, so then that would be the valid solution. Again, whatever the number that we have, we need to plug in that to the quantity, and we need to satisfy that the domain, it's greater than 0. Well, otherwise, it won't be a solution. It would be considered the invalid solution. Okay, so now, what about for the rest of the equation here? How do we solve for 42, 44, 46, and so on and so forth? Okay, we'll take a look at that. Again, just want to get some space here. There's so many property. And we used to have a formula quiz for the properties. But again, in pre-calculus, so you guys are going to see those same concept again. So we're going to have the formula quiz in trig and pre-calc. Okay, so now take a look at that, the other one here. So number 42, again, even for the natural log, we can still use the same property. So for the natural log, the only thing that we change is the name for the log. So instead of using log, we're using natural log. So natural log of xy, so that's considered natural log of x plus natural log of y. Again, condensed form to the expanded form. And then for the quotient, it's quite similar. So subtract. And then for the power, it's power to coefficient. And what about, for those you might be wondering, can we use the change the base for the natural log? So let's say that you do have natural log of x. Well, basically this one is just like a natural log of x divided by a natural log of e. Again, if the base is not shown. Okay? So now, let's find out what that is. So condense it first. So this one is natural log of quantity negative 4x minus natural log of 10. So once you condense it, so it's a natural log of negative 4x over 10. Difference to quotient. So that equals natural log of 6. And then for the natural log, so basically we can just cancel them out, or we can take the base e both sides. So cancel out that e to the power of natural log, because that's always what? 1. Again, so those are the basic property we talk about for the natural log. Natural log of 1 is 0. Natural log of e is 1. E to the power of natural log is also 1. So now what's left here? It's just negative 4x over 10. So that equals 6. And then solve for x. So multiply by 10 both sides. So we do have negative 4x equals 60. And then divide by negative 4. So that means x is what? Negative 15. Again, got to be careful with the solution that we find out. We need to plug in the number back to the quantity and make sure that it satisfies the domain. Again, for the parent graph of natural log, it's also like the one with the log. X is always greater than 0. So the quantity here, is that considered greater than 0? Negative 15 times negative 4, positive 60. It is greater than 0. Well, this one is fine. It's already in positive form. So it is the valid solution. And then what about for 44? Quite similar. So basically this one condensed them first. So log 9 over 4x minus 5. So that equals 1. Again, for log, if the base is not shown, it's always 10. So this one, the way to solve for this, convert it back to the exponential form. So 10 to the first power. So that equals 9 over 4x minus 5. So what we got here is 10 equals 9 divided by 4x minus 5. Keep that in mind. There's no denominator. That means the denominator is 1. Guess what we can do? Cross multiply. So 10 times the quantity of 4x minus 5. So that equals 9. So 40x minus 50. So that equals 9. In other words, 4x minus 9 equals 50. Add 50 both sides. So 40x equals 59. And then x equals 59 over 40. And check that. Is that reducible? No, because 59, which is considered a prime number. Okay, so 59 over 40. So plugging the number back to the original form. So make sure that the quantity is positive. It is positive because it's considered what? 40 over 10. So 59 minus 40. So that's 19 over, it's 19. So 19 over 40. Positive. So it is. It's a valid solution. Well, actually, you want to plug in the number back here. 44. And now what about for this one? So similar. So condense it. So natural log of x minus 4, over x. Difference to quotient. Same natural log. We can cancel them out or take the base e both sides. So that turns out to be 1 times the quantity. So it's x minus 4 over x equals 59 over x. Over 1, Cross multiply. So we do have 59x. So that equals x minus 4. Subtract x both sides. So we do have 58x equals negative 4. So x equals negative 4 over 58. Reduce it by 2. Or by 4. No, 4 is not divisible by 2. So which is what? Negative 2 over 29. Again, plug in a number back here. So what do you guys notice? Negative 2 over 29 minus 4. Wait a minute. It's going to be a negative quantity. So again, for this one, 46. Make sure that the quantity cannot be less than 0. If that's less than 0, that means what? No solution here. So this one, negative, plug in that to the quantity. So we do have a negative quantity. So no solution. So this one is considered the invalid solution. Or we can say that's an extraneous solution. So this one is considered invalid. And this problem here should be no solution. Okay, so now let's check 48, 50, and then I'll show you how to do 52 and the rest of this. Well, 48, it's quite similar, but let's take a look at that 50. So 50 looks like the inner quantity. We do have a quadratic function. If you guys do recognize the composition functions, so the overall picture is considered natural log, but the inner function, what is that? It's a quadratic. So again, same strategy. So we just want to condense them together. So it's natural log of 10 minus 3x squared times 6. And then the whole quantity equals natural log of 28. So this one, natural log, we can cancel them out. Well, what's left here? It's a quadratic equation. Distribute, so we do have 60 minus 18x squared. So that equals 28. Okay, making sure that this one is all correct. It is. And then swap those terms. So we do have 60 minus 28. So that equals 18x squared. So 60 minus 28, then that'll be considered 32. So that equals 18x squared. So 32 over 18 equals x squared. And then reduce. So 32 over 18, which is considered, well, divided by 2 top and the bottom. So we do have 16 over 9 equals x squared. And then for those you might be wondering, so quadratic, yeah, square root 2 solutions. So we do have plus minus 4/3. Okay, so got to be careful the way that to manipulate with the equation. So first thing you want to do, you want to condense it. And then once you see the same natural log on both sides, you can cancel them out because that e to the power, it's always 1. And then once you cancel those things out, it's quadratic, so that means you want to isolate the variable. Well, sometimes you actually have to bring everything together and then try to factor it. But this one, it's considered a monomial quadratic. So that's why we can isolate the constant and then take the square root both sides, so it's plus minus 4/3. Well, even if we put in the negative solution, that's going to work because the quantity is going to be considered positive. Alright, so now let's see what else. And 52, you want to convert that to the change of base form. So for 52, I'll just put it right up here. So that one is written as log base 7 of negative 5.21. So once you convert it, so it's log of negative 5.21 over 7. And you might be wondering, the quantity, it's negative. Well, it's log of 5.21 divided by log of 7. Change of base formula. Again, the quantity for this one cannot be negative. Got to be a positive number because that it doesn't satisfy the domain. Again, the x value for the quantity must be greater than 0. So this one would be saying that no solution. Or undefined. And then the rest of this is just condensing. So condensing, so we got what? Coefficient to power. So basically we can just take the coefficient back to the power position. So always try to do one thing at a time. And then it's all sum, so that means sum to product. So natural log of 10 to the power of 3 times 7 to the power of 12 times 11 to the power of 3. And for those who might be wondering, do I need to evaluate all this? No. You don't want to multiply that 7, 12 consecutive time. That's going to be crazy. And then the rest of this is quite similar. So take the coefficient back to the power positions. So coefficient to power, all coefficient to power. And then it's all sum. So that means we can condense it with the law, sum to product. So u to the power of 24, v to the power of 4, w to the power of 4. Put in parentheses like that. Expanding, so this one, rewrite it first, radical form to the exponential form. So d times a to the power of 1/3, b to the power of 1/3. And also at the same time can distribute that exponent. Because normally a times b times c with the cube root is written as what? A times b times c to the power of 1/3. And then what I did here, I just want to distribute the power. And expand it, so we do have natural log of d plus 1/3, natural log of a plus 1/3, natural log of b plus 1/3, natural log of c. And that would be the form. And then what about this one? Again, radical form, you can always convert it back to the exponential form. So that's c to the power of 5. And then square root of a, which is a to the power of 1/2. And then expand it, so log base 9, b, coefficient, bring it to the front, coefficient power to coefficient, so 5, log base 9, c, and then plus 1/2, log base 9, a. Okay, so the base, that's the common base right here, it's all 9. And now what about the last two problems? So how do we expand it? How do we evaluate with the given approximation? So here's what we need to simplify it first. So log base 9 of 33 over 32. Well, first thing that I can do, I can always use that to what? Quotient to difference. Can expand it. So log base 9 of 33 minus log base 9 of 32. So one thing that we noticed, 33, so that's what does that involve? It's considered 3 times 11. Okay, let me just put it right up here. So that one can be written as 3 times 11 for 33. Again, try to set up the factor tree for 33. It's 3 and 11. And then what about 32? So 32, that consists with what? 2 and 16. Or what else? A and 9. No, A and 4. Excuse me. A and 4. Okay, so we can use those type of property. Okay, so let's just expand it out. Minus. Well, there's no need to put in parentheses yet, so just want to rewrite it with that 32. So try to use the factor tree. So again, 32 is written as 4 and 8. Okay, so you see that in a minute, the reason why that I chose those number. So minus log of base 9, 4 and 8. And then what happened by the time you expand it? So we do have log base 9 of 3 plus log base 9 of 11. And minus, got to be careful with this. Once you expand it, you want to expand the inside parentheses here first. So log base 9 of 4 plus log base 9 of 8. Okay? So one thing that we noticed, log base 9 of 11, that's about 1.1. So log base 9 of 6, that's 0.8, but there's no need to use that here. And then log base 9 of 8. Well, log base 9 of 8, that's about 0.9. So one thing that we can verify here, so we can just use that log base 9, 11, and log base 9 of 8. But what about that log base 9 of 4? So what should we do with that log base 9 of 4? Okay, so now let's find out. So what we found here, we got log base 9 of 3. It's not given, but we can find it. Since we don't know what that is, so let's say that's x. So 9 to the power of x is 3. So that means x is what? 1/2. Because that 9, square root of 9, which is what? 3. So this one here, log base 9 of 3, 1/2. Again, the other one here, log base 9 of 11, that's given already. It's 1.1. So use that number. And then minus log base 9 of 4. Well, that's something we need to figure out. Okay, so that's something we don't know. So log base 9 of 4. And then log base 9 of 8. That one's given as well, which is 0.9. So negative, positive, minus 0.9. So try to break it apart and then expand it by using the properties of logarithm. So from there, so we can find out the solution. So now, log base 9 of 4. If you try to compare log base 9 of 6, log base 9 of 8, do you guys see the pattern or the structure here? So what's log base 9 of 4? So this one looks like it's an increment by what? By 0.1 for every even number. So just reduce this one down. That would be what? 0.7. Okay, try to approximate it. So I would say that this one, it's about 0.7. Okay? So let's just plug in the number. So for that one, we do have 0.5, 1.1, and this one is about what? 0.7 minus 0.9. So 0.5 plus 1.1, that's considered 1.6 minus 0.7, which is considered 0.9. 0.9 minus 0.9, that's exactly 0. Wow. Well, it's about 0, but it's actually about 0.00 something. The reason why that is 32, 33, those two numbers, they're pretty close. It makes sense, right? So log base 9 of 33 minus log base 9 of 32. So two close number. eventually it's about like 0.000 something. So if you try to round it up, it's about 0. And now what about for this type of structure without any number for the result? How would you evaluate log base 7 of 7 over 1,440 by using those letters? Again, so similar structure, you want to expand it. So log base 7 of 7 minus log base 7 of 1,440. So log base 7 of 7 is always 1, because 7 to the first power is 7, minus log base 7 of 1,440. So now, the problem is that for that 1,440, we need to break it apart with all those constant, 12, 8, and 10. Well, divided by 10, we do have 144 times 10. 144, that's considered what, 12 and 12? So that means this one can be written as 1 minus log base 7 of the quantity, 12 square times 10. Try to expand it, so we do have 1 minus 2 log base 7 of 12 plus log base 7 of 10. So it's 1 minus 2 times, well, what's log base 7 of 12? Log base 7 of 12, that's u, so minus 2u. What's log base 7 of 10? That's w, so minus w. So just the replacement, it's all about the substitution. So eventually it's 1 minus 2u minus w. Okay, so again, any questions, any concern that you have, or any comments, so feel free to put in that on the YouTube channel bar, and I'm more than happy to reply those comments and questions. Thank you for watching the lecture for chapter 6 today. And again, any question you have, so just fast forward, rewind, and also feel free to ask me any questions there. I'll see you guys next time. Take care.